All right, so let's look at the last example. The last one is rotation in geometry. So let me look at rotation. And just to be specific, let me pick rotation by 2 radians. So that means geometrically, if I want to introduce coordinate system, I would like the center of rotation to be the center of coordinate system, and then everything is rotated by 2 radians. So 2 radians is probably like that, and this point is transformed into that one. Boom. And that point is transformed into that one. Boom. So everything is rotated by 2 radians. Alright? Very simple geometric transformation. The whole plane is rotated about the center by 2 radians. Boom. Clear geometric transformation. What's the formula? Can we figure out the formula? Well, that is not so simple. Because the problem is that coordinates I have are Euclidean, and the resulting coordinates are Euclidean, and Euclidean coordinates are not well suited for transformations like rotation. Rotation is something about polar coordinates, not Euclidean. So I will work on that algebra later, and now let's try to do physics interpretation directly without a formula. So how would that look like? What kind of flow should we expect if for any point x, y, we have to assign a vector by this rule? A vector has 2 radians angle with the direction to this point. So the vector has that direction, and it has the same magnitude as the vector from origin to that point. So this is the vector. So the closer we go, the angle is still the same, so the direction of the vector is the same, and it goes there. And this point, the vector assigned to this point is going to be the vector having direction pointing that way, right? 2 radians. And the magnitude of that vector is equal to that. So it's going to be like that. And I'll take any point here. Consider direction of the vector being 2 radians. So the vector goes somewhat there, and the magnitude is equal to that. So what kind of flow is that? What happens to the center? Center is not moving, right? So center remains the same, and all the other points in a plane are moving. Now, is this a circulation? Well, not at all. Because this vector, velocity of this point, is not perpendicular to the radius. Why not? Well, because we know exactly what this angle is. It is not pi over 2. It is 2 radians. So this point has velocity that brings it closer to the center. And that point is moving closer to the center, and that is moving closer. Everything is moving closer to the center. So if you think about the motion of media and what happens to these points in the future, well, this point is going to move closer and closer and closer and closer and closer. And this point as well is going to be approaching the center while circulating around it. And that point will approach, and that point will also approach. So everything is converging to the center. how simple is that motion? Not simple at all. This looks much more complicated than this easy geometric transformation determined by rotation. Now, is this linear? Or is that linear? Would you consider that transformation as a linear transformation of a plane? Probably not. Well, maybe you will get suspicious because something like this, circulation in physics, happened to be linear transformation, right? So I didn't say it specifically, but you look at the formula. Well, the formula contains x and y in degrees 1 only, so it is linear. So this circulation in physics is a linear transformation. And, well, that doesn't look linear at all. But, in this case, you may be suspicious that this might be linear, possibly. But, is this linear? No. There is no way I can see that this motion, this flow of the whole plane is linear.